Assalamu alaikum. I hope you're doing well. So in this video, we will go over the VLSM approach using the binary method or by finding the magic number method. So I will try to solve the same questions, the VLSM exercises that I solved in the class with the cheat sheet method. Again, it's your preference, whichever way you want to go with, as long as you have the correct answer at the end. You can watch the other video for the cheat sheet method. In this video, I'll just go over the binary method or the magic number method. So let's take a look at the first question. You're given a network along with a network address, and you need to come up with the VLSM addressing scheme. So just like how we followed the steps for the cheat sheet method, in this method as well, the first thing you would write again is the network address that is given to you. So it would be 220 10 10 0 / 24. Okay, so again, this is rough, as in this is a rough way of doing it. You can do it on a paper or even on Excel, whichever way you prefer. So then the next thing again would be to list the number of hosts that are required in every subnet in the descending order. So the highest would be the first and the lowest would be the last. So in this case, the highest is 60 and then the lowest is 28. Now, what you need to do is you need to figure out how many bits would you require to get 60 hosts or almost 60 hosts, and how many bits would you require to get almost 28 hosts. How can you figure that out? You can find the power of 2 that will give you this particular number. So if you try to calculate the power, let's say 2 to the power 6, it would give you 64. So this is the number you're looking for. This is the number you need to find out. You can use the calculator to figure this number out. Just start with 2 to the power 1, 2, 3, 4, 5, 6 until you get a number, sorry, until you get a number that's close to the number that you require here. So in this case, we require 6 bits, and in this case, it would be around 2 to the power 5, which is 32, which is close to 28. So here we require 5 bits. I'll just clear this. Okay. Now, the next thing you need to figure out is the CIDR, or the CIDR, which is nothing but 32 minus this number. So 32 minus 6, and then 32 minus 5. This will give you /26 and then /27. These are your CIDRs. Now we will start figuring out the subnet addresses. And then along with that, we'll try to look at, we'll try to find the magic numbers. So the subnet address, I'll just write it here. For the first subnet, which has around 60 hosts, it would be the same address that is given to you in the question. So that would be 220 10 10 0. Okay, so that's your subnet address. Now you need to also figure out the magic number. Okay, now for figuring out the magic number, what you need to do is you need to convert sorry, you need to convert the CIDR to the subnet mask in binary. So that would mean if the CIDR is 26, that means you have 26 ones in your subnet mask, and the remaining are 0. Out of the 32 bits that you have, 26 of them are ones, and then the remaining, whatever remains, which is basically 6, would be zeros. So if you represent that in binary, it would look something like this. Let me use another color. 1, 2, 3, 4, 5, 6, 7, 8. That's one octet. 9, 10, 11, 12, 13, 14, 15, 16. That's another. 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. Okay. Now, what you need to do is you need to look at the octet. So these are different octets. This is your first octet, this is your second, this is your third, and then this is the fourth octet. You need to look at the octet that has the last one. So in this case, this particular octet is the one that has the last one, right? You need to now compare this with the bit representation. So if I write here 1, 2, 8, 64, 32, 16, 8, 4, 2, 1. So you need to figure out at which bit or at which power is the last one. So in this case, the last one is at 64, right? So that is your magic number here, 64. All you need to do is you need to figure out the last one, in which octet is it in, and then what is the binary or what is the bit representation for it. Okay, now here 64 is your magic number. What you need to do, and it's in the fourth octet, right? So in the subnet mask, you need to add 64 in the fourth octet because that's where you found 64, right? So it would look something like this: 2, 20, 10, 10 dot 64. Okay, that's your subnet address. Now, continuing these, you can even, one second. Now, for each of these, you can also find broadcast and the first and the last IP. So broadcast would be nothing but for finding the broadcast of, for example, the first network or for the first subnet, you need to look at the subnet address of the next subnet and just remove one IP. So it would look something like this: 220, 10, 10, 63. Okay. And then here, because we don't know what would be the next subnet, so it is helpful if you can find out the subnet address of the next subnet. In this case, it's not required. Your last subnet is the one with 28 hosts, right? So what you can do is you can figure out the magic number for this. You would, again, do the same thing. If I can show it to you. Now you have 27 ones, so you would add another one here to make it 27 ones, and you would see the last one is at 32. So that is your magic number, 32. And you need to add 32 to the subnet address to get the next network. So it would be 220, 10, 10, 64 plus 32. So this is 96. So this would be dot 96. And then the broadcast would be nothing but 1 minus this number. So it would be 220, 10, 10, 95. The first IP for the first subnetwork would be nothing but 1 plus the subnet address. So it would be I would just write FIP 220.10.10.1 and then 220.10.10.65. Why 65? Because this is 64, the subnet address. 1 plus the subnet address will give you the first IP. The last IP would be nothing but 1 minus the broadcast. So here it would be 220, 10, 10, 60, sorry, 62. And then this one would be 220, 10, 10.94. Okay, that's how you would solve this question. Now here, all you have to write, oops, sorry. Now here in the question, all you would need to write is what is the subnet address? So it would be 220, 10, 10, 0 slash the CIDR, which is 26. And then here it would be 220, 10, 10, 64 slash 27. Okay, now in this case, they're not asking you the additional IP, what's it called? Broadcast IP and the first and the last IP, but in your exam questions, you will have to answer those as well. So let's look at another question, a more difficult one, so this idea becomes clear. So let's pick this one, 10. So here you have, let's start with the same approach. The first thing you would do, sorry, the first thing you would do is you would write 16, 160, sorry, 160, 59, 128, 0, and then slash 19. That is the address given to you in question. Then you will start writing the hosts that are required in the descending order. So it would be 2000, 500, 230, 150, 230, 150, 75, then 45, I think. Yeah, 45, and then 14. Okay, and then you have these red lines here, right? These red lines, for each of them, you need to write 2. So you would just write 2, 2, 2. Those are your hosts. Now, you need to figure out the bits that are required. Again, you need to calculate this, find the number of, find the power for 2 that will give you this number. So if you find something around 2 to the power 11, it would give you 2048, and that would be 11 bits required. This would be 9, this would be 8, this would also be 8, this one would be 7, this one would be 6, this one would be 4, and this one would be 2, 2, 2. Okay, again, you have to calculate to find these out. Okay, if I can show you, there is one way you can do. You can just open the calculator, and if you pick the scientific side, you can just write 2 and press on this button, and then just keep changing the numbers. So in this case, if you use 11, it will give you 2048, which is close to the number 2000. So that's your bits. Now, in order to figure out the CIDR, you need to minus these bits from 32. So 32 minus 11, that would be 121. So that's slash 21. Then you have 32 minus 9, which is slash 23. 32 minus 9, which is slash 20, oh sorry, not 9, 8. slash 24, 32 minus 8 slash 24. This is slash 25 slash 26 slash 28 slash 30, 30, and then 30. These are your CIDRs. The next thing would be to figure out the subnet mask, subnet address, and then the magic number as well. Okay, and then alongside the magic number. So the first subnet address, like I told you earlier, it would be the same one that is given to you in the question. So this one would be 160.59.128.0. Okay, now to figure out the magic number, you need to use the CIDR for this subnet and convert it to subnet mask. So 21 slash 21 means there are 21 ones and the remaining are 0 from the 32 bits that we have. So it would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 20. Okay, that's where we stop, right? Oh, I'll write this one again. So this is 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. Okay, now here the third octet is the octet where you have the last one, right? So you'll represent that as with the bit representation. So 128, 64, 32, 16, 8, 4, 2, 1. Okay, so here the last one is basically where the bit representation is 8. So your magic number is going to be 8. Okay, and it is in the third octet. So to this address, you need to add 8 in the third octet. So it would look something like this: 160, 59, 136.0. Okay, now this CIDR is 23. We had 21 first, so 22, 23. Now the last one is at the second representation. So that means your magic number is 2, and you need to add 2 in the third octet because that's where we are currently. So 160, 59, 138.0. Okay, again, now this is 24. So we had 23 ones before, so we'll add another one here. Now your last one is at 1. So your magic number is 1, and you need to add 1 in the third octet. So 160, 59, 139.0. Okay. Now again, you have 24, the same CIDR, so you'll not change anything. The magic number is 1 again. So you would write 1 and add 1 to the third octet. So it would be 160, 59, 140, 0. Okay. Now your CIDR is 25. So that means you need another one, but it will be in the new octet. So now I will write my representation again here. So it would be 128, 64, 32, 16, 8, 4, 2, 1. I'm writing it up and down so there is more space and it is understandable. But if you have space, you can write it together. Now, the last one is at 128 and it's in the fourth octet. Okay, now we are in the fourth octet, so remember that. Your magic number is 128 and you need to add 128 in the fourth octet. So it would look something like this: 160, 59, 140.128. Now we've moved to the next octet. Okay, now again 26, so another one. The last one is at 64. So your magic number is 64. You need to add 64 in the fourth octet, which already has 128. So 128 plus 64 will give you 192. Okay, so it would look something like this: 160, 59, 140, 192. 28. So you need to add two more ones. We had 26 ones before. So 27, 28. It is at 16. Your magic number is 16. Add 16. It would be 208. So 160, 59, 140, 208. Now 30 ones. So you add, we had 28 before, so you would add 1 and 1. Two more. It's at 4 here, so your magic number is 4. Add 4. You will get 212. So it would be 160, 59, 140, 212. Again, 30. That means the magic number will be same. So 4, and then add 4 to 212. So this would be 6, 1, 2. Okay. So this will be 160, 59, 140, 216. Now it is best to figure out one more subnet address, so it will help you figure out the the last broadcast address. So again, 30 sider will give you the same magic number 4, and and the next subnet address would be 160, 59, 140, 220. Okay, so now the final thing would be to, one second. Now, the final thing would be to figure out the broadcast and the first IP address. Okay, so for the broadcast address, what we need to do is we will look at the next subnet address and just remove one for each of them. So here you would write 160.135.255 because this is the last IP in the 135, let's say 135 octet. And the third octet in the 135 address, this is the last IP you can have with 255. If you move next, it would start from 136.0. So similarly, you need to look at this one now and just remove one. So 160, 59, 137, yeah, 137.255. The next one you need to look at is this one. So 160, 59, 138, 255. The next one is this. So you would write 160, 59, 139.255. The next one is this. Here you need to remove from the fourth octet now. So 140 and then 127. Here it would be 191, 160, 59, 140, 191. Here it will be 207, 140, 207. Here it will be 160, 59, 140, 211. This is, here it would be 15, 215, 160, 59, 140, 215. And then here it would be 160, 59, 140, 219. Okay, now you don't need to find the broadcast for this one because this is an extra subnet that we tried to figure out. It was not required. So you don't need to figure out the other addresses for this. Now the first IP would be nothing but 1 plus the subnet address. So I will just write FIP. So here it would be 160, 160.59.128.1. 160.59.136.1. 160.59.138.1. 160.59.139.1. 160.59 140.1, 160.59, 120, 140.129. I think I messed it up. So this one is for this, and then this one, and this one is 160, 59, 140, 193, 160, 59, 140, 209, 160, 59, 140, 213, 160, 59, 140, 200 and this one would be 17. And the last IP is nothing but one IP less than the broadcast. So let me change the color. The last IP is nothing but one less than the broadcast. So I would just write the last two octets to save time. So it would be dot 135 dot, let me just write the whole thing, 160.59.135 dot 254, 160.59, 137.254, 160.59.138.254, 160.59.139.254, 160.59.140.126, 126, and then 160.59.140, 190, 160.59, 140.206, 160.59.140, 206, and this one would be 210. Oops, 210. 160.59, 140, 210. This one would be 214. And then this one would be 216. Sorry, 218. 59, 140, 218. Okay, so this is how you would solve it. The only thing that's different is basically finding the magic number based on the subnet and where the last one is in the subnet mask and the binary converted subnet mask. And basically that's it, that's how you would solve it. So let me know if you have any questions. Try to practice all of these questions in the VLSM exercise. They're a very good example of what you will see in the exam. If you have any questions, let me know. And that's it. Thank you for watching.